If you haven't seen my first video on the chain rule, go back and watch this. I'm going to base my first few examples on those previous examples, but I'm going to start to show you the shortcut way. Like always, we write a lot at the beginning so we understand what we're doing, and then by the end, we end up writing a lot less. So you're still going to be looking for the input and output functions, but I want to point out what we did. So the outer function in cosine cubed is something cubed. So the first thing we wrote in terms of derivatives was 3u squared. I'm going to say that a little bit differently. You'll see when I go back through these, I'm going to say the derivative of something cubed is 3 times that same something squared. Notice, we used to have u cubed, and then at the end we have 3u squared. Or maybe say that another way. We used to have cosine cubed, and we end up with 3 times a cosine squared. Okay? But when the input is another function, in this case cosine, we have to multiply by the derivative of that function. So we multiply by negative sine of x. I know I'm writing on top. That's what I'm used to. So how would I do this straight through? If I just had y is equal to cosine cubed x, I see that the outermost thing is the cubing. So the words I use to help you folks out is the derivative, here we go, of something cubed is 3 times that something squared. What used to be cubed? That's cosine. So I read a cosine in here, and our something is cosine, which has a rate of change of negative sine of x. So we're doing the exact same derivative, using the exact same logic. We're just doing less writing. Mainly, we're not writing the dy over du and du over dx separately and then multiplying to divide out the du's. So notice again, we're taking the derivative of cosine, the outer function, and we end up with a sine as the derivative of cosine. We start out with cosine of sine. The derivative of cosine is negative sine of u, or whatever was in cosine before. And then, since u was sine, the input was another function. We had to multiply by the rate of change, the derivative of that input function. So if I was given y is equal to cosine of sine of x, the derivative of cosine of something is negative sine of something. That's when we wrote negative sine of u down here. So I'd say the derivative of cosine of something is negative sine of something, and our something is sine of x, which has a rate of change of cosine of x. And that's what we ended up with down here. When the input to a function is another function, we have to multiply by the rate of change of that input function. We'll get to some other examples here, but one more looking back at our old work. So the outermost function was cosine. We took the derivative of cosine and got negative sine of u. Why did we get u in there? Because we had cosine of u, and the derivative of cosine of u is sine of u. Or the derivative of cosine, no matter the input, is going to be negative sine with that same input. So we're going to speed things up. If I'm given y is equal to cosine of 4x squared, I'm working outside in. The derivative of cosine of something is negative sine of something. Our something is 4x squared, which has a rate of change of 8x. Whenever I have an input like 4x squared that's not a plain old x to the first power, the chain rule applies and we have to multiply by that rate of change. In this case, 8x. Let's try one that has no work on it. So, do you see that this is a composition of functions, aside from the title at the top? 2x cubed is the input to sine. But no matter what, the derivative of sine is cosine. So the derivative, let's write dy dx is equal to, we can ignore the 3, that's a constant multiplier. The derivative of sine of something is cosine of something. Our something is 2x cubed, since 2x cubed is a function that's not a plain old x. We have to multiply by the derivative of that 2x cubed, 6x squared. We're going to skip this one. It's really ugly and scary. And we're just going to do a whole bunch of derivatives relatively quickly. I'll try to speak slowly but move quickly. So sine cubed, we could use the product rule, but you'll see the chain rule works a little bit more quickly with less writing, which is always a good thing. We're going to start with the outermost function, and the last thing you would do evaluating sine cubed of x would actually be the cubing. So I'd say the derivative of something cubed is 3 times that something squared. Our something is sine of x, which has a rate of change of cosine of x. You may want to go back and rewatch the beginning part of this video. All that extra work shows why we're allowed to skip that stuff. If I had done all of the long work with dy du and du dx, this line would have read dy du multiplied by du dx would be 3u squared times cosine of x. Because we would have rewritten the original y equals sine cubed as y equals u cubed, and u is equal to sine of x. Okay. So the derivative, there you go, dy dx, let's let you think, what's the outermost function? It's the 4th power thing. So the derivative of something to the 4th power is 4 times that something to the 3rd power. What was that something to the 4th power? Sine of x. And sine of x isn't plain old x, so we multiply by the derivative of sine of x, cosine of x. We're making a chain of derivatives. Chain rule. The derivative of, what's the outer function? Cubing. So the derivative of something cubed is 3 times that something squared. What was the thing being cubed? Tangent. And tangent of x has a rate of change of secant squared x. We're not worrying about simplifying. The derivative of secant squared x starts with the squaring, and the derivative of something squared is 2 times that something to the 1st power. Our something is secant of x, which has a rate of change of secant x tangent x. That 17 hopefully doesn't bother you at all. We're not going to write out 17 cosines multiplied times each other. We could, but that product rule would take a long time. So the derivative of something to the 17th power is 17 times that something to the 16th power. Our something is cosine of x, which has a rate of change of negative sine of x. Oh, finally we get an outer function that's not, I don't know, a polynomial x squared x cubed. What's the outer function for cosine of x squared? It's cosine. And the derivative of cosine of something is negative sine of that same something. Our something is x squared, which has a rate of change of 2x. The derivative of sine of something is cosine of that same thing. Our something is x squared, which has a rate of change of 2x. The derivative of tangent of something is secant squared of that something. Our something is 3x squared, which has a rate of change. Oh my gosh, no it doesn't. our something isn't 3x squared, our something is x cubed, which has a rate of change of 3x squared. Oh, this is very exciting. You actually have to use the chain rule 3 times. The outermost function is the cubing function. So the derivative of something cubed is 3 times our something squared. That something is sine of 2x. And you have to be careful here because sine has an input that's not a plain old x. So we have to think the derivative of sine is cosine of what? Same number, 2x, and that 2x has a rate of change of 2.